Hello friends, welcome to the session on microprocessors. In this session, we'll be discussing about 8085 instruction set. In this session, we will see what we mean by instruction, what is instruction cycle, machine cycle, T states, addressing modes for 8085, and also we will see the classification of instructions in the instruction set. Friends, as you know that you are viewing this session on my YouTube channel, and do subscribe to the channel to see many more videos on the various topics of the subjects of electronics and computer science. So let us start the session with the question what we mean by instruction set. Now, whenever we have been provided with a microprocessor, then it is possible that with the help of the microprocessor, you can design a microprocessor based system. And whenever you want to perform any function or any job by using this system, then it is necessary to feed the instructions to the microprocessor to perform a specific task or a job. So every microprocessor will have a certain instruction set, and these instructions, whenever they are fed to the microprocessor, then accordingly the job or task will be performed by the microprocessor. An instruction, you can say, is a binary pattern that is designed to perform a specific function. 8085 has a lot many instructions. Say for example, 8085 has 246 different instructions, and this entire group of the instruction is being called as an instruction set, and it will determine what function microprocessor can perform. Each instruction, whenever we want to represent, then it is to be represented by using the 8-bit code, and this code of the instruction is being called as a opcode, operational code, or sometimes it is also called as instruction byte. Many times this opcode is also called as hex code because this code is written by using hexadecimal number system. Instruction set of 8085 can be classified into different categories. So as shown in this diagram, we can classify the instruction set into different categories such as data transfer instruction, arithmetic instruction, logical instruction, branching instruction, and control instruction. So data transfer instructions, these are used to move the data from one register to another register or from register to memory. Say for example, whenever we write the instructions such as move A, comma B, then actually we are making the use of data transfer instruction. Arithmetic instructions are used to perform arithmetic operations such as addition, subtraction, increment, and decrement operation. Say for example, when we make the use of the instruction add B, then actually we are making the use of arithmetic instruction. Logical instructions are used to perform logical operations such as AND, OR, NOT, XOR. Say for example, when we write the instructions such as AND immediate 00, then this type of the instruction is being called as a logical instruction. Branching instructions are used whenever we want to jump from one instruction or one part of the program to another part of the program, then that is being called as a branching instruction. Say for example, whenever we write the instruction such as jump to 000H, then this is just nothing but a branching instruction where we are instructing the microprocessor to jump from the current statement to the statement which is located at this location. Control instructions are used whenever we want to perform any input or output operation on the I/O ports. Say for example, whenever we write the instructions such as out11, then this instruction can be called as a control instruction. So these are the different instructions. As far as this session is concerned, we will understand what we mean by instruction and what are the addressing modes. And as far as the different set of instruction is concerned, we will have the separate sessions on the data transfer, arithmetic instruction, logical instruction, branching instruction, and control instruction, where we will discuss in detail what these instructions are and how they are written and what kind of result can be generated by using these instructions. So let us understand first of all what we mean by instruction cycle. So every instruction, whenever we write any instruction to the microprocessor 8085, then it has a certain sequence of operations. So every instruction is being associated with certain sequence of operation, and these operations need to be carried out whenever that instruction is being executed by the microprocessor. And you will find that certain amount of time will be required to complete these operations, and this time period is being called as the instruction cycle. So as shown in this figure, this is the instruction cycle, where it will consist of some fetch cycle, execution cycle, where it will consist of the machine cycle and the number of T states. So the steps that are being required in the instruction cycle is the first step is the fetch, where the next instruction is fetched by the address stored in the program counter, and then it is stored in the instruction register. So whenever we want to execute the instruction, then that instruction need to be fetched out or need to be called, isn't it, from the memory address, and this address is being stored in the program counter of 8085, and then this instruction is being stored into the instruction register. Further, this instruction is decoded. So decoder interprets the encoded instruction. So every instruction has been written for specific tasks, so it has to be decoded. So decoder will perform this job. Then the effective address is being read, that is the address in the instruction is read from the memory, or the required data is being fetched. For many times in the instructions, we need to read data from the memory, and whenever we want to read the data, then the address in the instruction is being read and the required data is being taken. Now, finally, we need to make an execution step. In the execution step, the memory read, memory write, or IO read or IO write operations are to be performed. So this is the final step in the instruction cycle. Now let us understand what we mean by machine cycle and T states. So instruction cycle will consist of one or more machine cycle. So as shown in this diagram, say for example, this instruction cycle consists of 2 machine cycles. And every machine cycle will consist of number of T states. Say for example, the first machine cycle consists of 4 T states, and the second machine cycle consists of 3 T states. So what is machine cycle? Machine cycle, you can say it is the time required by the microprocessor to complete an operation of accessing the memory or input output device, and that is being called as a machine cycle. So machine cycle is the time required by the microprocessor to complete the operation, such as accessing of the memory or accessing of the input output device. T state, you can say that as shown in this figure, it is the one time period of the microprocessor clock cycle. So you can say that there are a number of T states in one machine cycle. So it is the time period between the 2 successive peaks of the clock pulses, and this is to be called as the T state of the microprocessor. So one machine cycle will consist of number of T states, and one instruction cycle may consist of number of machine cycles. Now let us understand what are the different formats that are being used for the instructions in 8085. There are 3 common types of formats that are being used for the instructions in 8085. The first format is being called as a 1 byte instruction. Many instructions for 8085 are 1 byte. That is, the opcode and the operand are being represented by only 1 byte. So 1 byte instruction will have only one opcode. The second format, say for example, whenever we write the instructions such as move B, A, then this instruction will have the opcode or hex code 47H. So H will represent that this is hexadecimal number, So this instruction can be called as a 1 byte instruction. Another type of the instruction format is the 2 byte instruction, where the first byte will indicate the opcode and the second byte will indicate its operand. So 2 byte instruction will have the format such as the first byte will indicate the opcode or hex code, and the second byte will indicate the 8-bit data or address. Say for example, when we write the instructions such as move immediate b comma f2h, then you will find that this instruction will have the hex code 06f2. So this instruction can be called as a 2 byte instruction. In this instruction, this f2 data is being moved to the register b. There is another format of instruction, and this format is being called as a 3 byte instruction, where the first byte indicates the opcode and the next 2 bytes will indicate the address. So in the address, we have the two parts, the lower part and the higher part. So lower order address is in the second byte and the higher order address will be in the third byte. Say for example, whenever we write the instructions such as load accumulator LDA 2050H, then the hex code for this instruction has to be written in the 3 byte format such as 3A5020. So one can easily observe that the address is 2050, out of which the higher bytes 50 are written first and the lower order uh, bytes 50 are written first and the higher order bytes 20 are written afterwards in the third byte. Now let us understand what are the different ways of having an addressing of 8085. So there are different addressing modes for the 8085. So addressing modes is just nothing but there are the different formats of specifying the operands. So whenever we specify the operands for a microprocessor 8085, then there are different formats that we can make the use of. And these formats are being called as the addressing modes of 8085. So there are 5 addressing modes in 8085. The first addressing mode is being called as the implied addressing mode, where the operand is implied in the instruction itself. Say for example, when we write the instructions such as STC, that is set the carry flag, then one can easily observe that the operand, that is the carry flag, is being mentioned in the instruction itself. Another addressing mode that is being used is the register addressing mode, in which the operand is the register. Say for example, when we write the instructions such as add C, then one can easily observe that the register C is being mentioned in the instruction itself. So say for example, suppose we have an accumulator where the content of the accumulator are 0000011111, because it is a 8-bit register, and suppose the register C has the content 00001000, and whenever we make the use of this instruction such as add C, then one can easily observe that the content of the C will get added into the content of the accumulator, and the content of the accumulator will be modified as 00001111. And this is an arithmetic instruction, and therefore after the operation the flags are affected. So one can easily observe that the flags are affected in such a way that the parity becomes 1 because it is an even parity, otherwise the other flags are set to 0. There is another addressing, and this addressing is being called as an immediate addressing, where the operand appears immediately after the opcode of the instruction. Say for example, when we write the instructions such as ADI08H, so in this instruction, this is an instruction which will represent add immediate. So the data is being mentioned in the instruction itself. So in such a case, you will find that the data will be directly added into the accumulator as far as this instruction is concerned. So if the accumulator consists of 00001100, and suppose you have a data such as 00001000, then one can easily observe that after the execution of this instruction, the accumulator content will be modified to 00010100, and the flags are also affected in such a way that the parity becomes 1, and also the auxiliary carry also becomes 1, because the carry is being generated at the position D3 and it is being passed on to D4, while other flags are set to 0. There is another addressing mode, and this addressing mode is being called as a direct addressing mode, where the address of the operand will appear after the opcode of the instruction. So for example, when we write the instruction such as LDA load accumulator 0200H, then we are asking the microprocessor to load the content of the memory location into the accumulator. So the address of the location is also mentioned in this instruction, and thus this instruction or such type of the addressing is being called as a direct addressing. There is another addressing, and this addressing is being called as the register indirect addressing, where the content of the register pair points to the address of the operand. Say for example, when we write the instructions such as add M, then we are asking the microprocessor to refer to the memory location of which the address is stored in HL pair, and then we are asking to add that content into the accumulator. So such type of the addressing is being called as the register indirect addressing. Now we will go for the classification of instructions. The first class of the instruction is being called as a data transfer instruction, or sometimes it is called as copy instruction. These instructions are used to move the data between the registers, or these instructions are move the data between the memory location and registers. Say for example, when we write the instructions such as move R1, R2, or whenever we write the instructions such as move R, M, then these instructions are just nothing but data transfer instructions. Arithmetic instructions, as its name indicates, these instructions are used to perform arithmetic operations such as addition, subtraction, increment, or decrement on the data in the registers or in the memory. Say for example, when we write the instructions such as add R or add M, then these instructions are performing the addition operation on the data in the register or in memory. There are certain instructions that are logical instructions. These instructions perform the logical operations such as AND, OR, XOR, compare, rotate, complement of the data in the register or in the memory and register. Say for example, when we write the instructions such as ANI data or XRA R, then these instructions are the logical instructions because they are performing logical operation. Certain instructions are called as the branching instructions. You will find that whenever we write any program for the microprocessor, then the instructions are executed sequentially one after the other. But many times we do not want such execution, and therefore it is possible that we can jump from one instruction to another instruction. So these instructions are used to perform conditional or unconditional jumping, calls, returns, and restart. Say for example, when we write the instructions such as jump and then the address, or call and address, then these instructions are just nothing but the branching instructions. Certain instructions are there that are being used to perform for the stack maintenance, or reading from the input port, or writing to the output port, or many times we need to read the interrupts, or we need to set the flags. Then these instructions are called as the control instructions. So for example, push RP or in the port number, these instructions are just nothing but the control instructions. So this is a set of instructions called as an instruction set for 8085. So the instructions that are commonly used by the people while writing the program for 8085 are being mentioned in this table. So this is the mnemonic, that is how to write the instruction, and this is the hex code of the instruction, or many times it is called as the opcode. So always you need to refer to this table whenever uh, you want to write any program, or whenever you want to execute any program by using the 8085 based system. So as I told you that in our next sessions, we'll be discussing in detail all these instructions, how to write them, and what is the meaning that is being associated with each and every instruction. So thank you, friends, for viewing the session. Hopefully you have understood what we mean by the instruction set of 8085 and how these instructions can be used. Thank you all for viewing the session.